All right, I guess I'll get started. This is the OpenCHAMI User Summit or User Project Community, whatever, for the HPSF conference. My name is Alex Lovell-Troy. I represent the TSC. I've been on the TSC since I helped to form the project. And I'll do a State of OpenCHAMI talk in just a few minutes. But some introductions or some getting started things. I'll be trying to keep time for myself and for others. So if you are speaking and you see me go like this, it means you have 5 minutes. And then if I go like this, you have 3 minutes. And you can guess what happens after that. So we don't have a big hook, but we will try to stay on time. Also, because of who we are and who's here, we may just decide to go off the schedule a little bit. If folks are coming in, we want to make sure that everything is relevant to the titles of what we proposed. But we've got people with specific interests in the project. And if we're heading down a path that isn't useful to the folks in the room, we should shift a little bit. Additionally, the microphone, you can't hear me through that, but the video is only going to have the sound that comes out of this microphone. So we need to make sure it's turned on, and we need to make sure that we're using it, and we need to make sure that we are repeating questions. One of the great things about being part of HPSF is that they're going to do a ton of work to make this all appear on YouTube, and then we can share it with others. So I don't know about others, but if you're speaking and you would like to have a copy of this to share with your boss or on your socials, that's how it's going to happen, and you will be very disappointed if you cannot be heard because you held the microphone way over here. All right. Are there any other questions before we get started? Well, we have a schedule that's up here that's very difficult to read. We will be doing these two talks, which is the state of the program, the state of the project, and then we've got Dell and HPE talking about how they are leveraging OpenCHAMI. We'll then have a break, and then we will move into the second half, which I'm pretty excited about. Our partners from Red Hat are here, and we want to talk about if we're going to start booting HPC systems using containers, or if we're going to start packaging system images as containers, how can we do this in a way that leverages more of the community? So these two talks are going to be focused around how do we want this to work, and how does this work within the context of the BootC project, which Red Hat has been. Did you originate it, or okay, you guys originated and are definitely sponsoring. So I'm pretty excited about that. My goal is that we'll come out at the end of the day today with an idea, a hypothesis of how we can converge on BootC and what we're doing for booting supercomputers, and then hopefully come out with a standard at some point so that others can benefit from the same thing. All right. The break is not listed, but I'll figure out what that is before, so no one will miss the coffee break. Without further ado, are there any questions before I move into the state of the program, state of the project talk? Right. And it's so nice to be able to hear the chapel talk at the same time. I think it's coming through the wall. All right. All right, so the OpenCHAMI Cloud-like HPC System Management. I've been giving this talk with some changes, some minor additions for a while now. It is the default way that I want to introduce the project to folks who have not used it before. I think many of you have used OpenCHAMI before, so this will be a review, but I'd still like to make sure that we're covering all the bases so we all start on the same page as we move through the rest of today and tomorrow to discuss the future of the project. Wow, these slides are going to look weird. Okay, so there was a motivation to create the OpenCHAMI project to handle HPC provisioning and booting. We felt like there wasn't a great answer that sat right at this intersection of the cloud habits, HPC realities, and operator constraints. And we needed something that we could run on our largest systems at LANL, but we weren't the only ones. So the rest of the consortium included, at that point, HPE, CSCS, NERSC, the University of Bristol. I don't think I'm forgetting anyone. And we all wanted something that was open source that we can contribute to, that we could try new things in, and we could explore new paradigms. This is because we had gotten used to the idea that cloud ergonomics are really useful. A declarative API is way better than like the shell of the console of a server. We wanted idempotent API first things. We've gotten used to that on cloud. We wanted a ton of that. The problem is cloud relies on over-provisioning to give you that flexibility. There's always another VM you can start up. There's always another API you can hit. Your credit card is not even really the limit of what you can do in the cloud. For us, when we buy a machine at Los Alamos, we want to use the whole thing all the time. We don't want to buy 30% more or a second machine just so that we can burst to do this. So the tools have to look a little different. You can't use the same methodologies for what we're trying to do that you can on the cloud. The reality is here that our weird interconnects, the scale of our systems, the fragility of our hardware, we typically have really new stuff that hasn't been used by others. So we don't have the benefit of a cloud vendor who can buy a rack and just, abuse it to try to figure out where the problems are and then get the second generation or the third generation that they actually deploy. What we get is often the first time that the vendor has really assembled a full system and tried to use it. And so we work well with our vendors to do hardware testing with them. That's not the kind of thing that you can do, that the cloud would offer to its customers. So the realities of HPC means that our hardware's more brittle, it doesn't change as quickly, and we need to be much more careful with provisioning. So our operator constraints. This was another thing that we had seen with the way that we've been running systems for the last couple of decades. There was a time when it was very true that we needed to measure the number of system administrators or the number of nodes per system administrator. How many machines can you manage with one sysadmin? And then you scale that linearly. That is no longer true in the cloud world at all. The number of VMs or the number of servers that you manage with one sysadmin is a ridiculous ratio, but it didn't used to be. And we're still operating in that world where we have to hire some number of people, and we have to know what the scaling factors of those are and how to do that. And those people are busy. We want them working on the broken hardware, right? We want them fixing the jobs. We want them helping to make our system run faster. So if there's a lot of like care and feeding operations that needs to happen, that's a distraction for them. When Los Alamos buys a system, and we're not the only ones that do this, we buy a system sometimes to install, run one job, 5 years, and then turn it off. And so if in order to do that, we have to plan 4 yearly downtimes to do control plane upgrades, like that's 4 times when our operations team can't do anything else. And that we feel like is not acceptable. And so in particular, like you look at this and you think, oh, Kubernetes might be a great fit for you. But the operator, the ergonomics of that, the upgrade cycles of that, the support cycles of that mean that those systems that are sitting there for 5 years, that's not realistic. Now we also have systems that want to do like training and inference and classical HPC jobs, and we want to run Slurm and Kubernetes, and we want to do all these other things. That flexibility is something that doesn't fit this same model where you leave it alone for 5 years. But we don't want to teach people 2 tools. We don't want to buy 2 tools. We don't want to work with 2 tools. We want something that can handle the simple case, and it also can handle the flexibility case. And so we didn't, when we got together as a consortium, we didn't see anything that felt like it offered that, and we didn't see anything that was likely to build towards that. And so we created the OpenCHAMI consortium in 2023 to get started with this. Our operators, our engineers, the leaders of these labs got together and said, let's build this as an operator-first platform, and let's make sure that this is something that we can all share the learnings from. So, yeah. So HPC operations is becoming more like the cloud, but with these differences. Now, one of the other things that we really liked about cloud ergonomics that we wanted to bring to this flexibility and the way that we were provisioning systems is this idea that you don't necessarily just say, I want this to be done, a script runs, and then you go and look to see the remains of the script, right? What you want is something that can evolve over time to observe, orient, decide, and act. This is a pretty standard strategy loop called the OODA loop. If you've ever done, management consulting. There's some room up front if you want to come on in. So this is also pretty typical of the way that all of the cloud tools work. So the cloud tools will try to provision a VM, and if it succeeds, great. If it doesn't succeed, then it just tries again. So your desired state that you want is 10 VMs. It gets 8 the first pass, it gets the other 2, and it's fine. We wanted something like this for our HPC systems that worked within the constraints I talked about before. So the ergonomics of an API-first system. So if we want this, and we want this for bare metal, what are the pieces that are missing? How do we build it? So OpenCHAMI decided that we were going to apply some of these processes. We were just going to say, okay, everything has to be modular, because we've got too many different use cases that are too different that we might want to deal with in different ways, right? We want stateless deployment options. This is allowing us to be wrong more often and to not be dealing with distributed state problems. We wanted something that would work really well at the simple single-use cluster site, but then we could move it over to this dynamic. So when you start with the idea of a stateless container or a stateless service that loads its data file and just runs from memory, that's the simplest possible way to operate a system. If you want to turn that into a SQL database later, you can do that. But if you don't have the option to do stateless deployment at the beginning, then a lot of your tests get a lot harder. Their integration happens longer. This is all part of the idea of opt-in complexity. So when we were building the project, when we started out, we said, look, the sysadmins that start to deal with a level of abstraction on top of a level of abstraction on top of a level of abstraction never learn how the core of it works. So we want to make sure that if we are going to make this optional stateless deployment or possibly a SQL server behind it, when you activate the SQL server, you're doing it on purpose, you know that you've done it, and you have access to the internal database. So that opt-into complexity has been a key piece of what we're doing. This is to support both ends of this spectrum. Containerized deployment options. Now, I said before, we didn't really want to do Kubernetes for the upgrade cycle, but that's not entirely true. We didn't want one Kubernetes cluster per system, but we think Kubernetes is a great way to deploy this if we're going to do many systems at the same time. And other sites have decided that they want to use Kubernetes for everything. But that meant that we had 2 different ways that we wanted to deploy OpenCHAMI, and so we said, look, maybe OpenCHAMI doesn't have a default deployment option. We just show you the recipes of how other people are doing it, and you get to choose. We'll provide containers and binaries and a few reference architectures for how to put them together, but it's up to you to choose what you want to do. That's actually been a really great choice for us because it helped us to learn Podman Quadlets, which is how we're using it at Lanel. And we've found that systemd is just enough automation for us. We don't need to go to Docker Compose. We don't need to go to the other pieces that are available. So this can work at this simple single-use cluster scale. We can also then choose to opt into more complexity and push it to hybrid, dynamic, multi-tenant use cases. Okay, so this is the only architectural diagram I'm going to show in here. And I thought that oh well. So that 1, 2, 3, 4, there should be a little thing right here that describes what those are. So I'll have to talk you through that. Ben, my apologies. Okay, so if we're talking about how we want to manage systems, what we're really getting to is how do we want to get an operating system onto a node booted with a specific personality so that it can do work. And when I say specific personality, that could be a login node or a compute node or a GPU node that's going to run a VM for each of the GPUs that are on the node. Those are all the personalities of these servers that we might want. We declare our intent. We say to our inventory system, here's the hardware I know we have. here's how I would like that hardware to be reflected, and then all of that happens in the inventory before we make any changes to physical hardware. Then when it's time, so when we start out by doing discovery, what hardware do we have? Magellan is the main tool that we use for this. It is our discovery system. It queries all of the BMCs in the data center and then populates a database of all of the things that it knows about. And so depending on the Redfish implementation, that might mean we know about every single stick of RAM and every single network device, or we may know very, very little because Redfish is a weird standard. And I think we're going to rant about that a little bit tomorrow. So this BMC discussion happens between Magellan, talks to the BMCs, it populates our inventory system, the state management database, or I forget what that's actually supposed to stand for. This service actually was open sourced by HPE and has become the backbone of our inventory. And it's also something we've inherited from the previous generation of CSM systems. So we first do discovery. We populate all of the hardware into our inventory. We then declare what our intent is by saying, here's the physical nodes that we would like to be login nodes or compute nodes or storage nodes or whatever we want them to be. And all of this happens without ever touching hardware. Then we say, hey, let's boot these things. And what happens is all of this intent that we had up here gets converted into an iPXE script that says, go get your image from over there, boot with these kernel options, like set yourself up. Once the node gets to sort of the multi-user run level, it queries for CloudInit information. And depending on what groups it's a part of, what our intent was, it's going to get a different set of CloudInit scripts coming in that describe what you want the node to be. So this might set, for example, a different syslog forwarder for every cabinet in the rack. And because these are generated on demand per node, these things can happen very quickly and they can be very, very specialized. We've also got something that is part of our OpenCHAMI system, which isn't really described here, that allows us to put secrets in our CloudInit and then deliver them securely to each node. So think your munge key, think your SSH keys if you really want to. So that's another piece of this puzzle. To put this a different way, we bootstrap by identifying the BMC connectivity. If we've got an HPE Cray EX cabinet, we've got a tool that's a single binary that can just take care of an entire cabinet at once. If it's not an HPE Cray cabinet, we've got tools for that too. We just needed a very, very simple thing called EX Bootstrap, which lives here. Then we connect to all of those BMCs. We find out what information is there. We populate it to the inventory. We declare groupings. Some of the things that we can do here, like, if it's got a GPU, then we want it to do one thing. But if it doesn't have a GPU, we want it to do another thing. And all of that is defined through groupings. Each node then does its standard iPXE, DHCP boot. It loads up its file system, which is fully remote, and then it gets its per node CloudInit, and at that point you're ready to go. This process is very fast, so we're looking at like power on self-test, enumerate all of the GPU RAM, all of that stuff, which can take as long as it takes and we have no control over. But once you get past that, we're at like 40 to 90 seconds before you're like ready to run Slurm. And we feel like that's an acceptable boot timing for what we need to do, mostly at Lamel, but it's being tested other places too. All right, so often people ask, what about security? What is your security model for this? One of the pieces that we felt was important is that we should not make security our opinion. Your site is going to have your own security opinions about what needs to happen. So we think your site IDP needs to talk to a token exchange service, and that token exchange service will give you a token that does OpenCHAMI ideas. So we've got this plumbed in to our demo. We've got this plumbed into some of the systems we're running at LANL. And it's really just a standard JOT token exchange system that you can use anything you want with. If you don't want to use this, you don't have to. You can turn off the JOT. You can turn off the authentication. And I know that sounds weird, But if you're operating in an air-gapped situation and you don't need it, you can turn it off, right? We talk about authenticate, authorize, and audit. All of those things are important, and the code bases that we have include middleware so that you get all three of those things with every single microservice if you turn it on. If you choose to turn it off, obviously you don't get that. All right, so this is an open source project that's been around for not quite 3 years. We're not done, and it's not perfect. So what do we talk about that is today ready to go and real? We have deployed this on 5 platforms at Los Alamos, and we are running it. We've got roughly 12, and I think this is out of date. We're closer to 20 active contributors now. And from all of the sites that are partners, plus we've had some volunteers from outside of our community that have come in and said, we would like to contribute. We are currently replacing legacy services while maintaining our stable APIs. If you caught Ben's talk yesterday about Fabrica, we've created a tool to generate these REST APIs, and we are regenerating them as we go. At the same time, we're running through all the tests to make sure that all of the classic APIs work, but this gives us a more modern and more upgradable and easier to maintain set of microservices. So Fabrica has already replaced our traditional iPixie service with a boot service. We're doing the same thing with our Cloud Init server. One of the things that we really wanted from the Cloud Init server was to be able to validate Cloud Init before the machine boots. We're now able to do that. Fruit tracking, boot orchestration, all of these things are coming. Next, we've got broader scaling options that are coming and more extensible control. So the way we have scaled OpenCHAMI today is we feel like with a single node, you can handle 1,000, 5,000, whatever nodes, 10,000 nodes probably. The constraint is DHCP because we run our own DHCP and it's automatically created for us, right? So if you can maintain the DHCP broadcast domain traffic somehow not getting filtered through DHCP relays or whatever, we don't know what the limit is for a single node. What we've decided is that we want to adopt a more of a cell-based architecture to limit the blast radius of any one change. So we're thinking that at LANL, we're going to do maybe one OpenCHAMI instance for every 256 to 512 nodes and scale those out horizontally as many as we need. In our initial tests, having a 2,000 node cluster that had 7 instances of OpenCHAMI, we didn't need an external orchestration system because the sysadmins were basically doing the same thing 7 times, and they were pretty happy with that. We know that we will eventually need something that is more push button, something that handles stitching these things together. We've got work that is headed towards that, but in the let's start simple and evolve to complex, at this point we don't have a problem that is preventing us from getting things done. We're learning more about where this should go, and we'll get to that soon. So this stateless horizontal scaling to stateful cell-based architecture, that's the transition I expect us to go through over the next year. All right, if you're new here, decisions happen in public, discussions happen in public. There's nothing there's no back room, for OpenCHAMI. So join us on GitHub, where you can find all the roadmap issues, all the RFDs. These are discussions that may or may not become decisions, and ADRs are decisions that we've made. We use different names for those because we want to make it clear when a decision has happened versus when we are discussing a decision. That was confusing it for a while. You can browse all of our PRs. You can pick an issue. You can join the discussion in these RFDs. We would love to hear what you have to say. Lately, we've been starting to do weekly office hours. We've got a public calendar that you can get to through our website or through Slack. Those have been very interesting. We had someone join recently who re-implemented OpenCHAMI from scratch in sort of a clean room way using AI. And boy, is that weird. Because it technically passes all the tests, but if you start going through the code, you realize that there's a bunch of assumptions baked into it that would fail at other sites. But it showed us the limits of our tests, and it showed us how our documentation is pretty good for helping to define what a re-implementation might look like. I think that shows that there are some ways that we can improve OpenCHAMI, some ways that we can use AI to do a better job with some of what we're working on. I was really excited to see that. There's a question in the back. What was the motivation for the clean room rewrite that we saw at office hours? I think it was someone new to the project, and I just think he wanted to try. He also wrote an MCP for OpenCHAMI, which he has contributed. I haven't used it yet, but it's pretty cool looking. And he also showed that he can replace our core DHCP-based DHCP system with Kia, and none of the other pieces had to change at all. And he's even got control stuff for that. So he's new as a contributor, and boy, with what he's done so far, I'm really excited to see the community grow in that way. The other thing, so definitely join the Slack channel. That a lot of discussion happens there. There's a mailing list, which is where you find out about things like this event. And then the weekly GitHub updates. I think the very first use of LLMs in OpenCHAMI was we created a GitHub action that automatically summarizes everything that's happened in GitHub for us for the week. And when I haven't broken it because it doesn't have the right access key or whatever, it does a really good job of summarizing what we're doing, what to watch, which things are getting stale. And I've found it really helpful, even though I am involved in pretty much everything that goes on. So take a look at all of these things, get involved. Everything is linked from github.com/OpenCHAMI or our website, openchami.org. I look forward to having you as a part of the team. All right, latest developments. I think this is even out of date. I did this like less than a month ago, and it's still gets out of date quickly. Okay, versioning and rollback for Cloud Init templates. This is something we shipped that allows us to make a change to a Cloud Init template that is going to be booted on a node and then reference the old one rather than having to re-edit it and re-edit it and re-edit it. That's really useful. ARM support. We now have ARM support in all of our containers. There was one straggler. We got it last week. We have an image builder, which I didn't talk about much because it doesn't really matter where your file system comes from. But we wanted to make sure that there was some option in the community. So the image builder that we use at Los Alamos is the one that is in our OpenCHAMI repositories. It builds OCI containers, OCI layered artifacts that you can boot on a supercomputer. So we've been doing a ton of stuff with that, and we're hoping to add a ton more of that following today. Minio, so we use S3 as a protocol for object storage. You may be aware that Minio stopped updating their public stuff. We needed to switch. We switched to something called Versity. It's something we had used at LANL. It was good. It's performant. It's fine. It basically maps POSIX to S3. Gave us something we needed. We've got Opal, which was our sort of authentication shim. The first time we wrote an authentication shim, we're going to replace that. We're going to see how much of that we can get rid of by using Vault or OpenBow or whatever we're going to use, right? We've started the process of building not just like what are our components, but what's the API for boot orchestration. I think there's some RFDs on that. There's a little bit of code. I'm excited about that, the cell-based architecture. And then where we can help, we always need help with testing and the operations guides. The tutorial, we work really hard to keep that up to date as the best way for you to learn how to use OpenCHAMI and how to get started with it. But development moves pretty quickly. So if you test it out and you find that it doesn't work, it's not because we're lazy. We may also be lazy, but it's not because we're lazy. It's because of the way things are going. So let us know, file bugs. We love to see the bugs on that. We are doing more testing, more boot config evolution, and yeah, I would love to see all of you at the office hours. The questions there have been really interesting. Not something where we're specifically coming with a we must get this done by the end of office hours. It's really for people to ask questions. Hey, I had this crazy thought. Maybe we could just do this, right? And that's it. This is our getting started guide. We would love to have you as part of OpenCHAMI. I'll take some questions. And also, before I forget, we've got fun stickers up here. If you didn't happen to get one so these are just different stickers than the HPSF folks have. So with that, I will say thank you and open it up for questions. Great. Everything's perfect. No one needs to know anything. Yeah, Ben? What's the biggest challenge with the OpenCHAMI community? It's been resisting comparing OpenCHAMI to other tools because so we've been asked multiple times to put up sort of like a comparison table on the website of what we're doing versus XCAT versus Werewolf versus whatever else, right? And I don't think that it's fair to our project or other projects because the scope is so different. We did a project with the Werewolf team where we created a bridge so that our inventory system could be used with their provisioning system. And I think that modularity is important. And we don't think that this is a place where if OpenCHAMI is successful, there's no place for these other tools. I think better together is always the way to go. Is that a good enough answer? Yeah. So as a volunteer, if you want to contribute, how do you get the testing environment? There's multiple ways. I think one of them, and I think we're going to talk about this, well, the first one is all of the microservices have their own testing. So if you're constrained to a single piece, that's the best thing. Like, don't try to build a whole environment, just use the one piece you want and test there. If you need to test them all together, follow the tutorial. The tutorial will give you a 4-node VM-based cluster that you can run these things against. You're not going to be able to test BMCs with that, but BMCs, you're going to need hardware for that anyway. But if you just want to get started and test some of the software, follow through the tutorial. You'll get an environment you can use for testing. Anything else? Yes, sir. To paraphrase the question, this sounds like it works pretty well with Dell and HPE. Where do we think that we should be going with something like Supermicro or I don't know, any Lenovo, any of the other integrators? And I think, so we actually do a lot of our testing at LANL on hardware that did not come from Dell or HPE. But the Redfish implementations are really where it falls down. So the Supermicro servers that we have are fairly old, and their Redfish implementations are so bad that we don't feel like it's worth it to use the Redfish discovery. So instead, we build a discovery like cheater file that says, here's the MAC address and here's the IP address of the node. So it still works with a Supermicro node. Everything else works just fine. It's just being able to do that discovery is a problem. So, yeah, there's nothing that would prevent it from being used with any of the hardware out there today. It's just if you want to take advantage of the Redfish portions, then someone is going to have to do the work to write the Redfish driver for that hardware. With Dell and HPE, we've been pretty lucky that the ILO and iDRAC work really well with what we've done so far. So we would just have to figure out where to go from there. Does that answer your question? Yeah. So the question was about the Cray specialty stuff that we inherited through the open source software that we got from HPE, and specifically the X name, which is a Cray field that not only describes the identity of the node, but physically where it is on the data center floor through one identifier. And as far as I know, Cray is the only company that integrates in that particular way. So we have actually an RFD for machine naming because we want to be able to still save things like, well, if we want a name that indicates all of those things, we want to be able to continue to use it. But for instance, I think we've talked to Dell. Dell has started the conversation of using service tags as one of the things that's important to them. There are other folks that want different things. And so we're working that through in our request for discussion so that the new node-centric API doesn't rely only on the X name as its primary key. But we haven't changed that yet because we don't feel like we know enough from the community about what it should look like as the next thing. So if you have opinions, I would love to have you contribute to the RFD. I would love to have you involved. And I think Dell and HPE would like that as well because they know their products really well. They don't know everyone's products really well. Yeah. All right. We've got one more? You a joke.
Did I violate a licensing agreement when
As I said before, the jokes do not get better. And for the recording, I will not repeat that joke. All right, so we're running up on time. I think next Jay and John are going to come up and talk about Dell and HPE respectively, and their work with OpenCHAMI. But I guess we've got 2 or 3 minutes to change over, and I'll get some water. All right, thank you very much.